of COVID-19 is a pandemic that covers the whole world. So we thought we'd look at real life lesson applications of this topic. So in the same way that this pandemic is covering the whole world, we wanted to take a few moments to cover the 4 subjects that we study in.
So what I'm going to ask my students to do is just draw or type 2 things they already know.
We have 8 words, as you can see in the array. So our first word is pandemic. A pandemic is a disease over the world. Quarantine is a place of isolation. Contagious is a spread from person to person. Wash hands means to use soap and water for 20 seconds. Cough is to expel air from lungs. Asymptomatic. Next, we'll look at the math behind social distancing. Again, a real-life mathematical application. Social distancing measures can play a critical role in controlling the spread of pandemics, but only if they're carried out properly. So here's a quick 1-minute video we're going to look at addressing the topic of the math behind social distancing.
Go outside only for essential activities. All because of this curve.
Flatten the curve.
The curve. This curve.
Flattening the curve.
It shows the hypothetical number of cases in a pandemic over time, without an intervention and with an intervention. The dotted line represents the capacity of hospitals and healthcare systems. If social distancing goes well, this curve will be flattened, allowing hospitals to take in and discharge patients without being overwhelmed. The result? More people will get access to the healthcare and attention they need, and hopefully, fewer people will die. But the x-axis represents time since the first case. If you lower the peak, the pandemic might last longer, because the number of new cases will be spread out over a longer period of time. But the question on a lot of people's minds is exactly how long will that be? Right now, the world is trying to both flatten and shorten the curve. Fewer cases and a shorter outbreak.
Okay, next, we're going to have a 1-minute discussion regarding the question, how likely are we to continue social distancing? What I'd like you to do is do a turn and talk and discuss with an elbow. Good job, everyone. Okay, our next aspect of our lesson is going to be looking at a 1-minute example, and the topic is going to be increasing arithmetic sequence. Okay, and we're looking at the fact that the common difference in this case is positive. We're looking at this example because currently we are unfortunately having a positive increase in the numbers of people infected with the coronavirus. This doesn't mean that positive is good, it just means that we're adding or increasing the number of people that are being infected right now. And we're looking to the day when we see a decrease. But right now we're going to look at this pattern or sequence in terms of the mathematical operation of addition. So let's look at our example. We have the numbers 5, 9, 13, and 17. The question that we ask ourselves is, what is the common difference between these numbers? So looking at our example, the question we'd ask ourselves is, what's the positive difference between 5 and 9? Well, we can see that the blue caret in the screen points to an addition of 4. So when we ask ourselves, what number do we need to add to 5 to get 9? The answer is 5 plus 4 equals 9. We continue in our sequence or our pattern, and we see that 9 plus 4 equals 13. And again, in our sequence or pattern, we see that 3 plus 4 equals 17. Our next example is a 1-minute activity where we're looking at identifying patterns. So we're going to continue each pattern, and we're going to look at this simply. We're going to look at the unshaded numbers for our pattern because those are numbers that also have a positive difference, which means they're addition sequences. So in the first pattern, we see 0, 6, and 12. So we know that the common difference between 0 and 6 is 6. So we need to say, what do I need to add to 0 to get 6? So the answer is 0 plus 6 equals 6. The next part of our sequence or pattern is what's the difference between 6 and 12? So we ask ourselves, what number do we have to add to 6 to get 12? And the answer is 6 plus 6 equals 12. In the next line in our sequence, we see 0, 7, and 14. Again, we have to ask ourselves, what number do I have to add to 0 to get 7? The answer is 0 plus 7 equals 7. Again, what number do I have to add to 7 to get 14? The common difference between 7 and 14 is 7. So 7 plus 7 equals 14. Our next aspect of probability, we're looking at our task to solve what is the probability of spinning an F. Remember in the beginning of our math lesson, we looked at the probability pie chart. So here we see it again in this problem. So in this problem, first, when we look at our pie chart, we have to ask ourselves the question, how many slices do we have in this pie chart? So let's count the slices. 1, and we'll start with Y. 1, 2, 3, 4, 5, 6, 7. Okay, so we know that we have 7 slices of the pie chart. So the answer is going to be some number out of 7. And we know that the question is asking, what is the probability of spending? So let's look at our pie chart slices. How many F's do we have in this pie chart? Oh, let's look at them. I see 1 orange F slice and I see 1 purple F slice. So that means the probability of spinning an F is going to be 2 out of 7.
That our country, the United States of America, is just your elementary school. The leader of your school is the principal. The leader of our country is the president. This is the federal. Easy one. What about the states? All of our country's 50 states have a leader too. That person is the governor. Each state, like each classroom in a school, is unique and different. The teacher is the governor of a state. You know the third level of government? We, the people, local students, parents, friends, everyone. You can imagine that your group tables in most classrooms is like the city council in your town. Council works to take good care of our community, just like students take care of other classmates in school supplies.
And then we're going to discuss, why people can't earn money right now. That means that the economy is down, and the economy is just what runs our, give and take, supply and demand, how we buy things, how we get things. And then we have to explain, people can't afford to live. And yes, the government helped and sent money to people, but that's temporary. And when you can't work for long periods of time, then people get really frustrated. So we're going to move into why should people wear masks and how the individual affects what happens in the government. So my example here is to show the students what cause and effect looks like. I'm going to say, well, the cause is what happens. What happens is I'm wearing a mask and then I sneeze, and I'm going to release 75% fewer particles, which means if I'm wearing a mask, only 1 out of 4 particles get through my mask. And if I don't wear a mask and I sneeze, I release 100% of the particles, just like that little girl. Then I'm going to ask the students to fill this out. I'm going to say, what happens when people can go back to work? Well, there's a positive effect. People can earn money, and then they're going to circle, well, when people can buy new things, the economy, does it grow or does it shrink? we're going to say, yes, it grows, and that helps a lot of people, businesses. And then the infected people release the virus. That's one of the negative causes. And the effect of that would be that people become sick again.
Particles that can invade living cells. There are millions of varieties with different behaviors, shapes, and structures. Coronaviruses are one group, named for their crown-shaped outline. 4 of these commonly infect humans. A lot of times when you get a cold, it's caused by a coronavirus.
Okay, so then we're going to look at the life cycle of a virus in depth. So here's a cute little drawing video. We can see that the way that a virus works is it doesn't spread unless it has a host. And so the host you see is that little pink blob, and he gets a little virus going into him. And that's called attachment. That's the first stage in the life cycle of the virus. After that, we have replication, so that one virus starts and makes another one. After that process happens, it's in assembly. So if you think of an assembly line, it gets materials out really quickly, it starts going. And as soon as you see that guy is all full of the virus, release. And that's like when you see release, all of the virus gets spread. So I'm going to do an example. You can see that these pictures are in different orders, and they're all of kitties. Well, cats and kittens, I guess. And so I'm going to show you first, for cats, we're going to be born. So first, cats have to be born. And then they're a little kitten, and they're young. And then they're a cat. And then here's a little tomb of a kitty, because mammals die after old age. Now I'm going to ask my students to go ahead and put these in order, and students would have the ability to go through
to create your writing sample. Okay? So here we are. Sometimes people get sick. When someone gets sick, it's because of germs. Germs are tiny things that live all around us. There's a new sickness called the coronavirus. The coronavirus germs spread very easily. If a bad germ sticks on me, I can get sick. I need to wash my hands a lot so that I can stay healthy. When I wash my hands, I can sing happy birthday or count to 20. This will make sure my hands are clean and I stay healthy. Sometimes so many people get sick that my school might need to close. If my school closes, they will clean it. While they're cleaning my school, I will stay at home. I will stay safe and healthy at home. I will do fun things at home. My teacher might have sent me some things to work on while school is closed. They will keep my brain working hard. I will go back to school soon. My parents and teachers want me to stay happy, healthy, and safe. The end. Thank you for listening. So we listened to our background text. And so we're going to look at learning to make predictions using clues in our writing. And we're going to look at our state standard. It's Colorado State Standard. It's a writing process to plan, draft, and write a variety of informative texts. Our audience today, again, is going to be third graders, gifted and talented students, culturally and linguistically diverse students. We're going to have 3 students, and our word clues that we're going to use in our writing samples, and I'd like you class to write these down, are the words virus, social, distancing, healthy, home, school, order, end, mask, and safe. So I'd like you to use at least 5 of these words in your writing sample, and ideally, I'd like you to try to use all of the word clues in your writing sample today. And so our standards writing process is used to plan, draft, and write a variety of informational text. Our objective today will be that students will be able to practice making predictions and support their thinking with evidence from the text. The materials we'll use is our background text that we just read, background vocabulary, which we heard earlier from slide 4, a list of word clues, which we just went over, a writing journal, or a computer, which is a UDL component, either for students who utilize text-to-speech or for gifted and talented students who would prefer to type their writing sample rather than write it in their journals. Okay, and now we have a video that we're going to listen to our 1-minute video clip. Here we go.
The great enemy of writing isn't your own lack of talent, it's being interrupted.
You've probably been told to stay indoors, limit contact, and go outside only for essential activities. All because of this curve.
Flatten the curve.
The curve. This curve.
Flattening the curve.
It shows the hypothetical number of cases in a pandemic over time, without an intervention and with an intervention. The dotted line represents the capacity of hospitals and healthcare systems. If social distancing goes well, this curve will be flattened, allowing hospitals to take in and discharge patients without being overwhelmed. The result? More people will get access to the healthcare and attention they need, and hopefully, fewer people will die. But the x-axis represents time since the first case. If you lower the peak, the pandemic might last longer, because the number of new cases will be spread out over a longer period of time. But the question on a lot of people's minds is exactly how long will that be? Right now, the world is trying to both flatten and shorten the curve. Fewer cases.
So our next aspect is going to be a very short 1-minute discussion. What I'd like you to talk about is, when should we lift the stay-at-home order? Turn and talk with an elbow partner. Okay, wonderful. Our next example is going to be a 1-minute exercise. We're going to reference our background text for this. So according to the text, the coronavirus spreads germs easily. Our source is the Easter Seals, Illinois Autism Partnership. So that's an example of text evidence. So bear that in mind. When you're writing, you're going to be mindful to use your word clues, and you're also going to cite text evidence, which means evidence that you actually find in our background knowledge text. Our final activity is an example. We would practice washing our hands for 20 seconds, which is very important. You can sing happy birthday to yourself twice when doing this exercise. We're going to look at now our claim, evidence, and reasoning. So our question or topic that I'd like you to choose for your writing sample, you can choose one of 2 questions. You have an option. How long will social distancing last amid the coronavirus? Or you can choose to address the following in your writing sample. When should we lift the stay-at-home order? Remember, the claim, according to our text, is that the coronavirus spreads germs very easily, and our source is the Easter Seals, Illinois Autism Partnership. Remember, when you're providing your text evidence, always be sure to include the words according to the text, and make sure you use appropriate punctuation using a comma and then quotation marks to cite the evidence that you find directly from the text. Next, you'll follow up with reasoning, and you can provide 2 reasonings, two aspects of reasoning. One could be, when should we lift social distancing? Or you can also use reading to address the question, if we should lift social distancing, when should we do it? If not, you might want to reason why not. And again, cite the source of your evidence. Remember to use an example such as, according to the text, tiny germs live all around us. So that's the evidence that I would use in a writing sample to support the reasoning that yes, we should continue social distancing because tiny germs live all around us. Is to create a math addition or number pattern, like the example that we worked on in class. Or you can be creative and use your blank piece of paper and create your own probability wheel, which might look like the 7-slice pie chart that we saw earlier. Also, a writing exit ticket would be your finished writing sample to answer the question, when and if to lift social distancing.
Exit ticket is filling in the cause and effect answers, those 3 questions that we saw on the slides, and the life cycle sequencing activity. So we would just put the sequence of the life cycle of the coronavirus in order to show that we know that life cycles can be different over different kinds of.
So thank you so very much for touring the world and the classroom with all 4 of our Common Core subjects, math, science, social studies, and writing, as we look at real-life applications of our current global pandemic. And most of all, we're looking ahead to times when we are not in the midst of a pandemic and we can happily return to life as we once knew it. Have a great day and stay safe, everyone. Thanks for coming to school. And thanks for spending time with Haley and Suyan. Bye-bye.